Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we'll look at changing the subject of an equation. So let's look at an equation like this. So this is still an equation because it has an equal sign, but it's slightly different than the ones we looked at previously because it has two variables. In fact, this is called a rule because it has two variables. Now, what we know here is that we can't actually solve this for x. We can't find a specific value for x because x depends on another variable y. So our solution isn't going to look like x equals 4 or x equals minus 2.5 or whatever. Instead, what we're going to look at is changing the subject of equations like this. Now, we call the subject of the equation the thing that's by itself. So for this equation, x is the subject of the equation because it's by itself, because it's written in the form x equals blah, blah, blah. You know, if the equation was like z equals blah, 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 z would be the subject of the equation. So I said before that we can't solve an equation like this. What we're going to do is change its subject. We're going to make y the subject of the equation. What we're going to do is rearrange this equation so that it's in the form y equals something. So what we're going to do is we're going to follow the same process, the same steps that we would if we were solving for y, because we want to make y the subject. So if I was solving for y, if I wanted to get y by itself, I would subtract 2. But if I subtract 2 from the right-hand side, I must also subtract 2 from the left-hand side. So this equation would become x minus 2 equals y. Now it's in the form y equals something. I mean, of course, you know this is the exact same as writing y equals x minus 2. Now we have an equation where y is the subject. So we have successfully changed the subject of this equation. All right, now let's look at a harder question. So we're going to take this equation here and we're going to make y the subject. We're going to rearrange it so like this one here, it's in the form y equals something. So this type of equation is very important when we come to do linear relations because you have to get y by itself in order to figure out the gradient of this line. So promise, later in the year you will thank me for teaching you how to do this. Okay, so what we're going to do is we're going to sort of pretend we're solving for y. So how are we going to get y by itself? Well, firstly, I want to get rid of this 2x, right? So I just want to move it to the other side. So I don't want to divide everything by 2 because that wouldn't get rid of the x, right? A lot of people think, oh yeah, I'll divide by 2, but that won't help us. What we're going to do is we're simply going to subtract 2x from both sides. Because if I subtract 2x from the left-hand side, they cancel out. No more x on the left-hand side, which is what I want. But remember, if I subtract 2x from the left-hand side, I must also subtract from the right-hand side. So I'm just going to be left with negative 5y, this was a negative, equals 10 minus 2x. Now, please remember like terms. 10 minus 2x is not 8x. These are not like terms, so I can't subtract 2x from 10. I just leave it like this. Okay, so if I was solving an equation that looks like this and I want to get y by itself, what would I do next? Well, this is minus 5 times y. So if I want to get y by itself, all I'm going to do is divide each side by negative 5. So dividing negative 5 cancels out timesing negative 5. So I'm just left with y on the left-hand side. Now, if I'm dividing this side by 5, I need to divide everything by 5. So 10 divided by minus 5 gives me minus 2. But I must also divide negative 2x by negative 5. So that is just minus 2 divided by minus 5 becomes a positive. It's just 2 over 5 times x. How easy is that? And then we're done. So if this was linear relations, we'd be able to read off the gradient here. That's why this is important. All right, now I'm just going to do one more example involving measurement. So let's look at this question here. So what we have is a formula for the surface area of a triangular prism where the base is an equilateral triangle. So the formula is it's base times height plus 3 times base times length. So you don't need to know how I got this formula, how it was derived, because we're not doing measurement in this video. Just trust me on this for now. So the first thing I'll do is rearrange this equation to make L the subject. So I'm going to take this equation and rearrange it so it looks like L equals blah, blah, blah. So the first thing I'm going to want to do is get rid of this BH, because that has no L's in it. So I'm going to subtract BH from both sides. So then I just get 3BL equals S minus BH. So now I've got L here, but it's been multiplied by 3B. So to undo multiplying by 3B, I'm going to divide each side by 3B. So then the left-hand side just becomes L, the right-hand side is S minus BH, all divided by 3B. Okay, so it's important I've got to divide the whole thing by 3B. I'm actually done. Now I've rearranged this formula so that L is the subject. So let's look at B. What value should I make L, which is the length, if I am told that I want the surface area to be 80 centimeters squared, the base to be 2 centimeters, and the height to be 1.73. So this is where rearranging formula is very important. Sometimes I want to solve for things like in measurement, like I want to find the radius of a circle or the length of a shape when I already know the surface area, or volume. Rearranging formula is very useful here. And the reason it's useful is because I've already done the hard work. I've got L by itself. So if I want to find out what value I should make the length, if I want the surface area 80, base 2, height 1.73, all I need to do is substitute these three numbers into this formula. Easy as. So I simply have L equals surface area, which was 80, minus base times height, all divided by 3 times base. And you just put that in your calculator, you should get about 12.76, and it'll be centimeters. And then we're done. How easy is that? Rearranging formula is very important. Please let me know if you don't get it. Thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.